Assalamu alaikum and welcome back to our lecture series on CAF3 Data Systems and Risk. Today we begin with one of the most fundamental parts of our discussion on big data. Now, before we dive deep, let's pause for a moment. When I say the word data, what comes to your mind? Maybe you think of numbers in an Excel sheet or a list of names in your phone book or maybe pictures stored in your gallery. But when we talk about big data, we are talking about something much larger, much more complex, and often beyond the capacity of traditional tools to handle. So, to truly understand what makes big data special, researchers and professionals often describe it using certain characteristics. These are sometimes called the V's of big data. Originally, there were just three: volume, velocity, and verity. Over time, more V's were added, such as veracity, value, variability, visualization, and even validity. Let's go through these one by one, slowly and clearly, with examples so you can connect the theory with the real world. Volume simply means the amount of data. Think about Facebook, which has billions of users. Every second, photos are uploaded, messages are sent, videos are streamed, and comments are posted. This generates terabytes and petabytes of information daily. Now imagine trying to store or process this with your normal laptop. Impossible, right? That's why we say the volume of big data is enormous, much larger than traditional data sets. The reason we even call it big data is because of this massive volume. Velocity refers to the speed at which data is being generated and needs to be processed. Let's use a simple example here. Imagine you are watching a cricket match live. The sensors in the stadium, the live camera feeds, the commentary on Twitter, and all this data is being produced instantly. If this data isn't processed quickly, it loses its value. For example, predicting the winning probability in the middle of the game is useful, but if the analysis comes 3 days later, nobody cares. So, in big data, velocity is about real time or near real time data flow. Next comes variety. Unlike traditional data, which might all look the same, say numbers in a spreadsheet, big data comes in many formats. For instance, structured data like bank transactions or student records, semi-structured data like XML files or JSON data from websites, and unstructured data like videos, social media posts, satellite images, or audio recordings. This mixture of formats is called variety, and it's a key reason why big data is complex. Now, let's talk about veracity. This means the trustworthiness or quality of the data. Not all data is reliable. For example, think about fake news spreading on Twitter or spelling mistakes in survey forms. Big data often comes from uncontrolled resources, so it might be incomplete, inconsistent, or even misleading. That's why organizations must work hard to clean, verify, and check the accuracy of their data before using it. This V is very important. Big data is useless unless it creates value. Think about a retail store. They might collect millions of customer receipts, but the question is, can they use this data to recommend products, improve sales, or reduce costs? If yes, the data has value. If not, it's just digital garbage. So, value means extracting meaningful insights from data. Variability means the data can change in meaning or context. For instance, a word like viral could mean something positive in social media but something dangerous in healthcare. Also, data flow may not always be consistent. Sometimes huge spikes happen, like during elections, natural disasters, or global events. Organizations must handle this changing and unpredictable nature of data. Another modern characteristic is visualization. With so much data, humans cannot just look at raw numbers. We need graphs, charts, dashboards, and even 3D models to see patterns clearly. For example, Google Maps uses visualization to show traffic conditions in red, yellow, or green. Without this, raw GPS data would be meaningless to most users. Finally, validity. This is about whether the data is correct, relevant, and applicable to the problem being studied. Imagine collecting data about rainfall to predict student exams performance. The data may be accurate, but it's not valid for that question. So, validity ensures that data truly fits the purpose. So, to summarize, the characteristics of big data are often described as a collection of V's, starting with volume, velocity, and variety, and extending to veracity, value, variability, visualization, and validity. Understanding these characteristics is the foundation because once you understand what makes data big, you will also understand why we need new technologies, new methods, and even new ways of thinking to manage it. Now that you know what makes big data, our next question is where does all this data come from? Big data is not born in a single place. It flows into organizations from many different sources, sometimes structured, sometimes completely messy. To understand big data management, you must understand its sources. So, today we'll break this into categories and I'll give you examples for each. Let's begin with social media. Think about Facebook, Twitter, Instagram, TikTok, even YouTube. Every photo you upload, every comment you make, every like you click, it's all data. And not just personal updates, companies also monitor hashtags, trends, and even the tone of conversations. This is a gold mine for businesses, governments, and researchers also. So, social media is one of the biggest sources of big data. Next, we have machine generated data. This is data created automatically by machines, sensors, and devices without human involvement. For example, sensors in airplanes measuring temperature and engine performance, or GPS devices sending location updates. Similarly, Internet of Things devices in smart homes like smart meters and wearable watches. This type of data is often huge in volume and high in velocity. Third, transactional data. Whenever you make a bank transfer, swipe your credit card, or purchase something online, a transaction is recorded, right? These records are structured and organized, perfect for analysis. Retailers, for instance, can study purchase history to predict what you might buy next. Banks can detect fraudulent activity by checking unusual patterns. Another source is web and log data. Every time you browse a website, the server records details like your IP address, the time you visited, what pages you opened, and how long you stayed. Companies use this to improve websites, analyze customer behavior, or detect cyber attacks. For example, Amazon can track which products you view most, even if you don't buy them, and then recommend similar items later. Governments also release massive datasets like census records, tax data, health statistics, and weather data, and many more. For instance, NASA provides open access to satellite images. The World Bank shares global economic datasets. Such open data initiatives are valuable source of big data for researchers and organizations. Healthcare is another huge contributor. Think of electronic health records like X-rays, MRI scans, DNA sequencing, and even fitness tracker data from devices like smartwatches. The healthcare industry generates enormous amounts of data daily, and analyzing it can lead to life-saving discoveries. Inside organizations, systems like enterprise resource planning or simply ERP or customer relationship management or also be called as CRM and HR systems continuously collect data. This could be employee performance records, customer complaints, or supply chain activities, all becoming part of big data. Don't forget multimedia. Photos, videos, podcasts, music, presentations, all are forms of data. With platforms like Netflix, YouTube, and Spotify, this type of data is exploding. Finally, scientific research itself generates massive datasets. For example, the Large Hadron Collider at CERN produces petabytes of particle collision data. Also, climate research generates continuous global temperature and environmental readings. This kind of data is critical for innovation and progress in science. So, if we put this together, the sources of big data include social media, sensors and machines, transactions, website logs, government and public data, healthcare systems, business applications, multimedia content, and scientific research also. Every one of these contributes to the ever-growing ocean of data around us. And the truth is, the list is still growing. With new technologies like Internet of Things and 5G, new sources appear every day. So far, we have learned what big data looks like, its characteristics, and where it actually comes from, its sources. Now, let's ask a very practical question here. How do organizations actually collect all this data? Remember, data does not just appear neatly in one folder. It flows from many sources, sometimes structured, sometimes unstructured. To make use of it, organizations need effective collection methods. Now, we will explore the main methods through which big data is collected in the real world. First, there's direct data collection. This means organizations collect data straight from users or customers. Examples include are like online surveys or feedback forms or registration data when you sign up for a new app, and similarly transaction details when you purchase a product. This is structured, deliberate, and often consent based. Companies like Amazon or Netflix ask you for details so they can personalize recommendations. Second, we have web scraping. This is a technique used to extract large amounts of information from websites. For example, a company might scrape product reviews from competitor websites or collect pricing data to compare trends. Web scraping tools automatically browse pages, copy content, and save it for analysis. It's especially useful for text and sentiment analysis. Social media isn't just a source of data, it's also a method of collection. Organizations use social media monitoring tools to track hashtags, mentions, likes, shares, and even emotions behind posts. For example, during elections, analysts track public opinion by monitoring Twitter conversations. In business, companies analyze brand reputation through Facebook and Instagram trends. Another powerful method is through sensors and Internet of Things devices. Think about your smartwatch, tracking your steps, heart rate, and sleep cycles. Or think about sensors in smart cars sending real time data about speed and performance. Factories use Internet of Things sensor to monitor machines, while cities use them for traffic management and pollution control. Also, this type of data collection is usually automatic and continuous. Every time a transaction happens, data is automatically captured. This includes point of sale systems in shops, and online payment gateways and also bank transfers and credit card usage. This transactional data provides accurate and structured records, perfect for pattern analysis. Whenever you interact with digital systems, you leave a trace. These traces are stored as log files. For example, web servers record visitor activity. Mobile apps log user actions. Security systems log login attempts. This is passive data collection. You may not even realize it's happening. Governments, NGOs, and organizations often provide open data portals where anyone can download data. For example, World Health Organization publishes health statistics. Anyone can access the data. Similarly, NASA shares space and satellite data. National weather agencies publish climate records. Researchers and businesses can collect these datasets to support decision making. With billions of smartphone users worldwide, mobile apps are a major collection method. Apps collect location data, browsing habits, preferences, and even microphone or camera inputs with permission. For instance, Google Maps collects real-time traffic data by monitoring phone GPS signals. Ride-hailing apps like Uber also rely on mobile data. Finally, there's crowdsourcing. This is when organizations invite the public to contribute data voluntarily. For example, Waze, a navigation app, asks users to report traffic jams or accidents, and also citizen science projects invite volunteers to record bird sightings or environmental changes. This method harnesses the wisdom of the crowd to collect large, diverse datasets. So, to sum it up, methods of big data collection range from direct forms of like surveys and transactions to indirect forms like log files and Internet of Things sensors, and even collaborative methods like crowdsourcing. Each method has its strengths and weaknesses. The choice depends on the type of data needed, the cost of collection, and the ultimate goal of analysis. So far, we have looked at what makes big data unique, where it comes from, and how it's collected. Now comes the exciting part. What do we actually do with all this data? Big data is not just numbers sitting on a server, its real power lies in its applications. Across industries, organizations are using big data to transform decision making, improve services, and even change the way we live. Now we will explore the major applications of big data with real-world examples. Let's start with the business world. Companies use big data to understand their customers better. Retailers like Amazon study purchase histories to recommend new products. Netflix analyzes your viewing patterns to suggest movies and shows you will probably enjoy. Similarly, marketing teams use data to personalize advertisements so you see exactly what interests you. The result increased sales, satisfied customers, and stronger brand loyalty. So, in business, big data drives customer insights, targeted marketing, and sales growth. Healthcare is one of the biggest beneficiaries of big data. Doctors use electronic health records and medical scans for diagnosis. Wearable devices track patient heart rates, glucose levels, or physical activity in real time. Researchers analyze DNA sequencing to study genetic diseases. Similarly, hospitals use big data to predict outbreaks or manage emergency rooms more efficiently. Imagine predicting a heart attack before it happens because of continuous monitoring. That's the power of big data in healthcare. Banks and financial institutions also rely heavily on big data. For example, for fraud detection, if your credit card is suddenly used in another country, the system instantly flags it. Similarly, for risk management, banks analyze loan applicants' histories to assess repayment ability. Also, algorithmic trading, stock markets use big data to make split-second buy or sell decisions. In finance, big data ensures security, efficiency, and smarter investments. In education, big data is shaping how students learn. For example, online platforms like Coursera track student progress and recommend courses. Universities analyze dropout patterns to support at-risk students. Teachers can personalize lessons using student performance data. This is called learning analytics and it helps make education more adaptive and effective. Governments also use big data to improve society. For example, smart city initiatives use traffic sensors to reduce congestion, and weather forecasting systems analyze climate data to predict storms and floods. Law enforcement uses predictive policing to identify high risk crime areas, and census and population data guide policy making. So, big data helps governments make data driven decisions for citizens' welfare. Transportation and logistics. Think about Uber, Cream, or delivery companies like TCS. They rely on big data for real time route optimization, tracking vehicles and packages, and also predicting traffic conditions, managing fuel efficiency and cost. Even airlines use big data to optimize flight schedules and improve customer experience. Agriculture. Yes, in today's world, even farming uses big data, like sensors measure soil moisture and nutrients. Drones capture images of crop health. Weather data predicts rainfall patterns. This helps farmers increase yields, save resources, and make agriculture more sustainable. Entertainment platforms thrive on big data. YouTube recommends videos based on viewing history, where Spotify creates personalized playlists like Discover Weekly, and Sports Analytics uses big data to evaluate players' performance and even design strategies. Entertainment becomes personalized and interactive thanks to big data. With the rise of cybercrime, big data is critical for security. Systems analyze billions of logs to detect unusual activity. Similarly, AI algorithms identify malware patterns, and organizations predict and block cyber attacks before they happen. Without big data, modern cybersecurity would be nearly impossible. So, big data applications are everywhere in business, healthcare, finance, education, government transportation, farming, entertainment, and cybersecurity. The key takeaway is big data is not about data itself, it's about how we use it to generate value and solve real world problems. So far, we have been amazed by big data, its characteristics, its sources, how it's collected, and all the wonderful applications it has in business, healthcare, education, and even beyond. But here's the reality, working with big data is not easy. In fact, the bigger the data, the bigger the problems. Now, we are going to talk about the challenges of big data, the difficulties organizations face when they try to manage, process, and use it effectively. Understanding these challenges is just as important as understanding the benefits because only then can we develop solutions. The first and most obvious challenge is volume. Big data means petabytes or even exabytes of information. Storing such massive amounts safely and affordably is a huge issue. Traditional storage systems like a single database server cannot handle this. Organizations need distributed storage systems, cloud platforms, and advanced compression techniques. and even then, costs are high. Data quality and veracity. Remember the V of veracity. Not all data is clean or trustworthy. Big data often contains errors, duplicates, missing values, or even fake information. Imagine running medical analysis on incorrect patient data. The consequences could be life threatening. Ensuring accuracy, consistency, and reliability of big data is a massive challenge. Data comes from multiple sources like social media, sensors, transactions, healthcare records, government portals. Each source has a different format. They could be structured, unstructured, semi-structured. Combining all these into one unified system is extremely difficult. This challenge is called data integration, making sure everything fits together for analysis. Big data doesn't just sit quietly, it keeps coming at high speed. Think about Twitter, millions of tweets per minute, or stock markets, thousands of transactions per second. Organizations must process this in real time, but traditional tools like Excel or even old databases cannot keep up. This is why specialized frameworks like Hadoop or Spark are used. Still, handling the velocity is a constant challenge. Another major challenge is data privacy and security. Big data often contains sensitive personal details like names, bank accounts, medical histories, and even locations. If hackers get access, the damage is enormous. At the same time, organizations must also follow privacy laws like GDPR in Europe or PICA in Pakistan. Balancing usefulness with privacy protection is one of the toughest challenges. Big data requires expensive infrastructure like servers, cloud storage, high-speed internet, and skilled professionals and maintenance. Small organizations may struggle to afford these. Even large companies must continuously invest because the scale of big data keeps growing. Skilled workforce. Having the data is one thing, having the right people to analyze it is another. There is a shortage of data scientists, data engineers, and machine learning experts worldwide. Without skilled professionals, big data cannot be transformed into meaningful insights. Data governance and compliance. Governments impose strict rules on how data is stored and used. For example, GDPR in Europe requires companies to protect personal data. Financial institutions must keep records for auditing. Similarly, healthcare organizations must secure patient data. Meeting all these legal and ethical requirements is a major challenge. Visualization and interpretation. Collecting data is one thing, but making sense of it is another. Massive data must be turned into visuals like dashboards, graphs, charts that humans can understand. If not, decision makers may be overwhelmed or misled. So, creating clear, meaningful, and accurate visualizations is also a challenge. Finally, technology itself changes very fast. A tool that's popular today may be outdated tomorrow. Organizations must constantly upgrade their systems, train staff, and adapt to new methods. Keeping pace with this rapid evolution is a continuous challenge. So, when we talk about big data, we must remember both sides, the opportunities and the obstacles. The challenges include volume, quality, integration, processing speed, privacy, cost, skills, compliance, visualization, and rapid change. Organizations that succeed in big data are the ones that don't ignore these challenges but actively find ways to overcome them. In our previous topic, we talked about the challenges of big data. the hurdles that organizations face while trying to store, process, and secure massive amounts of information. Now, let's shift gears and look into the future. The world of big data is not standing still. New methods, new technologies, and new applications are constantly being developed. These are what we call emerging trends. If challenges are the problems, then trends are the solutions and opportunities that guide us forward. Today, we'll explore some of the most important emerging trends in big data. One of the biggest trends is the merging of big data with artificial intelligence and machine learning. Why? Because humans alone cannot process petabytes of data. Machine learning algorithms can detect patterns, predict outcomes, and even make decisions automatically. For example, banks use AI models trained on big data to detect fraudulent transactions. Similarly, Netflix uses machine learning on viewing history to personalize your recommendations. This combination of big data and AI is shaping industries everywhere. Earlier, organizations analyzed data in batches, hours or days after it was collected. But now, the trend is toward real-time analytics. Streaming data tools like Apache Kafka and Spark Streaming allow instant processing. For example, ride-hailing apps like Uber and Cream process live GPS data to match riders and drivers in real time. Similarly, stock exchanges use real-time analytics to make split-second trading decisions. The Internet of Things is growing rapidly. Billions of devices, from smartwatches to industrial machines, are connected and constantly generating data. This trend means smart homes that adjust lighting and temperature automatically, smart cities that monitor traffic, waste, and pollution in real time, factories using Internet of Things sensors for predictive maintenance. The Internet of Things revolution is fueling the next wave of big data growth. Traditional storage is no longer enough. The trend now is towards cloud platforms and data lakes. Cloud services like Amazon Web Services, Google Cloud, and Microsoft Azure provide scalable and flexible big data storage and processing. Data lakes store raw data of all types, structured, unstructured, and semi-structured, in one central place. This allows organizations to scale up or down easily and reduces costs. With Internet of Things growing, not all data can be sent to a central cloud. That's where edge computing comes in. Edge computing means processing data closer to where it is generated, like in the device itself. For example, a self-driving car processes sensor data instantly on board instead of waiting for cloud servers. Similarly, smart cameras analyze video footage locally to detect suspicious activity in real time. This trend reduces delays and makes systems faster. Given rising concerns about cyber attacks and data misuse, privacy and security are now a major trend. Techniques like data encryption, anonymization, and blockchain are being used to protect sensitive information. For example, in healthcare organizations, providers anonymize patient records before sharing them with researchers. Another trend is the automation of data handling tasks. Instead of humans manually cleaning, transforming, and preparing data, automated tools do it. This reduces errors and saves time. These tools are part of what we call data ops, applying DevOps principles to data pipelines. Predictive and prescriptive analytics. Organizations are moving beyond just describing what happened toward predicting what will happen and even prescribing what actions to take. For example, retailers predict future shopping trends, and similarly, airlines prescribe the best routes and fuel usage based on predictive weather patterns. This is where big data becomes most valuable, turning past data into future insights. Another emerging area is the use of big data in blockchain technology. Blockchain itself generates massive transaction data that needs analysis, whereas big data tools are used to monitor cryptocurrency trends, detect fraud, and analyze decentralized finance markets. This crossover between big data and blockchain is becoming very important. Finally, as the world becomes more environmentally conscious, there is a trend towards using big data for sustainability. For example, energy companies analyze data to reduce waste and improve efficiency, whereas farmers use precision agriculture to minimize water and fertilizer use. Also, governments analyze climate data to fight global warming. In other words, big data is not just about business, it's about creating a more sustainable future. So, the emerging trends in big data include AI integration, real time analytics, Internet of Things growth, cloud computing, edge processing, enhanced privacy, automation, predictive analytics, blockchain, and even sustainability. These trends are shaping the future of industries and redefining how organizations think about data. Big data technologies. This is our final topic in this chapter. Up till now, we have talked about what big data is, where it comes from, how we collect it, the challenges we face, and the emerging trends that are shaping the future. But here is the key question: what technologies actually allow us to manage and process big data? Without powerful tools, big data would just be a messy ocean of information. Now we will walk through the most important big data technologies and platforms that organizations use today. I know many of you are not from an IT background. Maybe when you hear names like Hadoop, Spark, or not only SQL, they sound like strange creatures from another world. Don't worry, I'll take you from the basics all the way to the advanced tools used today. So let's begin this story of big data technologies. Imagine you have a tiny notebook and you are recording the names of your classmates. That's simple. Now imagine recording the names of every person in your city. You might use a register or a spreadsheet. But what if you had to record the names, phone numbers, photos, and fingerprints of every person in the world? Could you store all that in the notebook or a simple Excel file? Of course not. This is exactly what happened with organizations. The amount of data grew so big that traditional tools failed. So, new technologies were born. Let's meet them one by one. Hadoop, the pioneer, is like the first zero in big data. It is an open source framework, meaning it's free for anyone to use and modify. It was designed to store and process huge amounts of data by dividing the work among many computers. Think of it like this: instead of one person trying to read 10,000 books alone, Hadoop gives 100 books to each of 100 people and they read together. Teamwork. Hadoop has three important parts: Hadoop Distributed File System, or simply HDFS. This is the storage system. It breaks big data into smaller pieces and saves them across many computers. Then MapReduce. This is the processing system. It divides a big task into smaller ones, process them in parallel, and then combines the results. At the end, yet another resource negotiator or yarn. This manages resources. making sure every computer in the cluster is being used efficiently. So, Hadoop was the first breakthrough that made big data manageable. Next comes Apache Spark, the speedster. Apache Spark does not stand for an acronym, it's just the name. But think of it as the spark that speeds up big data processing. If Hadoop was the first hero, Spark is the superhero. Spark is also open source and was created to handle big data, but it's much faster than Hadoop. Why? Because it processes data in memory, like RAM, instead of writing it back and forth to disks. Spark can do batch processing, handling data in large chunks, real time processing like analyzing live tweets as they happen, machine learning, training models on big data, graph processing like understanding networks like social media connections. If Hadoop is the slow but steady worker, Spark is the fast and smart one. Next, let's talk about not only structured query language databases. You might know about Excel or relational databases like Microsoft Access, where data is stored in tables. That works well for small, neat data. But big data is messy, like text, images, videos, sensor readings. For this, we need more flexible databases, like not only SQL databases. So, unlike traditional databases, this can handle different kinds of data easily. For example, MongoDB stores data in a document-like format like digital folders. Cassandra handles huge amounts of data across many servers. And similarly, HBase works closely with Hadoop for structured storage. So, if relational databases are strict librarians who only allow neat rows and columns, not only SQL databases are friendly librarians who accept books, magazines, photos, and even videos. Organizations also use data warehouses and data lakes. A data warehouse is a structured storage system. Think of it as a library where all the books are carefully arranged, catalogued, and easy to find. Tools like Amazon Redshift or Google BigQuery are popular data warehouses. And a data lake is much more flexible. It stores raw data in its original form, whether structured or unstructured. Imagine a giant ocean where all types of fish live together. Tools like Hadoop HDFS or Amazon Web Services S3 Simple Storage Service act as data lakes. So warehouses are for neat and organized data, lakes are for raw and messy data. Cloud computing, renting superpowers. In the old days, companies had to buy their own expensive servers to store and process data. But now, with cloud computing, they can rent storage and computing power from providers. Cloud means the data is stored on remote servers and accessed over the internet. Big players include Amazon Web Services, which offers services like S3 for storage, Redshift for data warehousing, and also Microsoft Azure has HD Insight and Synapse Analytics. Similarly, Google Cloud Platform provides BigQuery, Dataproc, and Dataflow. Cloud computing makes big data affordable, scalable, and accessible. Raw numbers are hard to understand. This is where data visualization tools come in. They turn data into graphs, charts, and dashboards so humans can see patterns. Popular tools are like Tableau, Power BI, QLixSense, Google Data Studio. These tools are like artists painting a clear picture out of messy numbers. Big data becomes truly powerful when combined with artificial intelligence. For this, we use machine learning frameworks like TensorFlow by Google, PyTorch by Facebook, Scikit-learn, which is Python-based toolkit. These frameworks allow systems to learn from big data, predicting customer behavior, detecting fraud, or even recognizing faces in photos. These are the thinkers who make sense out of the massive data we collect. ETL tools are like the cleaners. ETL stands for extract, transform, and load. These tools act like cleaners and organizers of big data, where extract is like pulling data from different sources, and transform is like cleaning it, fixing errors, put it in the right format, and load is like saving it into a warehouse or data lake for use. So popular ETL tools are Apache Nifi, Taland, and Informatica. So if data were raw vegetables, ETL tools are the chefs who wash, cut, and prepare them before cooking. Stream processing tools are like the live reporters. Some data cannot wait. It needs to be processed live. This is where stream processing tools comes in. For example, Apache Kafka handles high-speed real-time data streams, and Apache Flink advanced stream and batch processing, and also Apache Storm real-time event processing. Think of them as live reporters delivering news instantly rather than giving you yesterday's headlines. Finally, with all this sensitive data, we need protection. That's where security tools and blockchain come in. Encryption makes data unreadable to outsiders, and blockchain creates a secure, tamper proof ledger of transactions. These technologies ensure privacy and trust. Blockchain and security tools are the protectors, like guarding the kingdom of big data. So, we started with the problem, traditional tools failing to handle the explosion of data. Then we met the heroes of the big data world. Hadoop, the pioneer, Spark, the speedster, not only SQL, the flexible librarian, warehouses and lakes, cloud platforms, visualization artists, AI thinkers, ETL cleaners, streaming reporters, and blockchain protectors. Together, these technologies form the ecosystem that makes big data not just possible but powerful. And with that, we have completed our exploration of big data technologies, the tools behind the scenes that drive the future of data. And with that, dear students, we have reached the end of our journey through the chapter on big data. We started by asking what makes data big. We discovered the characteristics, volume, velocity, variety, and more. We then looked at the sources from social media and sensors to government data and scientific research. We explored the methods of collection, direct surveys, web scraping, Internet of Things devices, crowdsourcing. We saw the applications, how big data is transforming industries from healthcare to business, from education to agriculture. We also faced the challenges like privacy, cost, integration, and the need for skilled experts. Then we stepped into the future with emerging trends like AI, real time analytics, Internet of Things, cloud, edge computing, and sustainability. And finally, we met with the powerful technologies like Hadoop, Spark, not only SQL databases, warehouses and lakes, visualization tools, machine learning frameworks, ETL systems, streaming platforms, and blockchain. Through all of this, one truth became clear: big data is not just about data, it's about insights, decisions, and change. So, as you reflect on this chapter, remember big data is everywhere around you. Every click, every step, every purchase, every message contributes to it. And in the hands of skilled professionals, it has the power to improve businesses, save lives, and even shape the future of our planet. Thank you for staying with me through this chapter. In the next part of our course, we will build on this foundation and explore how organizations actually put these big data concepts into practice.